Today we're going to be talking about G1, and it basically is everything that we talked about when it comes down to having angle relationships or things like this, where you're basically identifying each pair of angles that you see. So the first one that you have here, as you can see, we'll call this little L, we'll call this little Q, and then we'll call this little p. Okay. Remember, when we want to identify lines, we want to identify them with lowercase. So this is our transversal. So line L will be the transversal that we have. Little q and little p, we know something important about these two lines. These two lines are actually parallel to one another. What we see is that we're trying to look at this angle here. We'll call it x. And this angle here, we'll call it y. And what we know about these two angles, that they're actually inside the two parallel lines that we have. So because they are in the inside of the two lines that we have, we're going to call them, they're opposite to one another. So we're going to call them alternating interior angles. So these are alternating interior, okay, angles. We could go ahead and abbreviate just for this part of the webinar so that we know where we're at. Very simple. You just got to remember the rules and what you are expecting to see from the angles, or basically the lines that I give you that are cut by a transversal. So we're going to continue with the next one. The next one that we have, okay, again, we're going to give these lines a name. We're going to call this little L, little P, little Q. And with little p and little q, we know that these two lines are parallel and it's cut by a transversal. We have an exterior angle and then we have an exterior angle. They're opposite to one another, so we call this alternate exterior angles, okay? So alternate exterior angles. Super simple. You just got to remember. We're going to label this to be little l, little p, little q, and little l is a transversal of the line set that are parallel, which in this case is going to be P and Q. So remember, when we want to write something like this, we want to be able to identify it. We want to be able to say, or if we wanted to name these, remember that we have P that is parallel to Q, okay? So little p and little q, they're parallel. And what I'm looking at is I'm looking at angle X and I'm looking at angle Y. And I notice that these two are vertical angles, okay? So they're vertical angles to one another. Super simple, just part of the definition. We have little l, little p, little q. They're in the same side, okay? So they're in the same side, they're on the right hand side, the two angles that I'm looking at. They're both in the inside, okay? So they're right next to each other. So we call these to be the consecutive. So we call these to be consecutive, okay, interior angles. Okay, so these are consecutive interior angles. Nothing much to that. Now this is where it gets really interesting, okay? So once we understand that we have alternate interior angles, now that we understand that we have alternate exterior angles, we're going to go ahead and then move on to understanding how to be able to solve for, let's say, x for this example. Okay, so the first thing that you want to notice is, don't name these, but let's go ahead and call this one little l, little p, little q, and little l is the transversal of the lines that are parallel. As you can see that they're marked here. Okay, so they're marked here for you so that you understand. What I'm noticing now is that I have one angle and I have a second angle. They're on the same side, right? They're on the same side. They're on the left hand side, as you can see, but they're in the inside, right? So what do we know about these two angles? We know that these two, if they are called consecutive angles, they are supplementary. Okay, remember what the word supplementary means? Supplementary means that we add the two angles and they equal to 180. So that's what I'm going to do now. I'm going to go x plus 128. That's my first angle. I'll put it in parentheses so you guys can see the difference of what I'm talking about. And then I'm going to add it to my second angle, which in this case will be x plus 68. And what I'm going to do is I'm going to go ahead and set it equal to 180, which is perfect for us. I'm going to take them out of the parentheses. So now I have x plus 128 plus x plus 68, that is equal to 180. And I'm going to combine things that are alike. Okay, so that's all I'm going to do here. So I'm going to say that I have these two that are the same. So I have 2x. And then I have the following two, 128. Okay, so I have 128 plus 68. When I go ahead and I add them up, I get a total of 196, which is equal to 180. From here, remember, all we have to do now is be able to solve, okay, for x. And this is a two-step equation where I use the subtraction property of equality, where I get to subtract 196. Let me make some extra room here. That simplifies to 0 for us, remember that. And we have 2x that is equal to, and now I'm going to subtract these two numbers together. So I have 16. I apologize, I have negative 16. To be able to get x by itself, remember I'm going to have to do the division property of equality. So I get to divide both sides by 2, and I end up with x that is equal to negative 8. Now, remember what the instructions said at the beginning. All we want to do is be able to solve for x. And in this case, x is negative 8. Now, we are allowed to have the variable x, or any variable that we have here. We're allowed to have them be negative. That is okay. What we're not allowed to have, though, is negative angles. So please understand the difference between that. This is okay. We are okay with having negative 8 for x. But we're not okay if we have 128, let's say, for example, but it's a negative 128. That cannot happen. So before I move on, is there any other questions that you have for this particular question? Here is the next question for us. It's saying, please find the measurement of the angle indicated in bold. For us, this is going to be this one here. So that's the one that I'm going to be looking at. Okay. Again, these are not labeled for us, so let's go ahead and label. We'll call this little p, little l, and then little o. These are lines, remember. The little red markings here, or the little arrows that you see here, they are basically telling us that little l and little o are parallel. Remember that, okay? So now, this is what I need you to notice. I need you to notice of what you have. You have your first angle to be here, and your second angle is here. What do we notice about these two angles? They're right next to each other. And if I look at the way that it follows along here, I'll put it in a different color so that you can see. This part right here, I'm noticing that it's half a circle, right? It is a line that they're in. So we can say that the addition of these two, so I have x plus 88 plus x plus 108, are supplementary to one another, right? They're supplementary, not to one another. They're supplementary. That means that they're a linear pair, and they're going to equal to 180, which is great for us because we know how to do that, right? We take the two that we have. We're going to go ahead and look at these two together. We have 2x, and then we have 88 and 108. Okay, so we go 108. Let me clear this. 108 plus 88 will give us 196. So we have plus 196. And what I want to do now is set it equal to 180. And then I'm going to go ahead and subtract what we have here. 196. That simplifies, and I have 2x that is equal to, just like last time, negative 18. Oops, negative 18. Negative 16. Sorry, I keep on saying 18, I don't know why. So let me make some room here. I do the division property of equality. And then I go ahead and I simplify this to be negative 8. Now, the difference between this one and the last one, remember the last one said just find what x is. This time, let me go ahead and erase this really quick. What I want to know is what's this highlighted part. So I'm going to have 8x plus 108. And what's that going to be equal to? Because this is the one that I'm interested in. Okay? That's the one that I need to figure out. I need to know what it is. So all I want to do is I want to substitute what I know about x. So what do I know about x? Well, I know that x is equal to negative 8. So I have negative 8 plus 108, and that's going to equal to 100. So this degree here is 100 degrees, which makes this one here to the left. If you look at it, let me erase this really quick so you guys can see it. This angle here, if you substitute 8 in for x, you're going to end up with 80. 80 plus 100 will still give us that 180 that we were looking for. So the next example that we have, what I'm looking for here, is going to be, go ahead and figure out what x is, okay? That's what I want to know. I want to figure out what x is. Can you guys give me a second? Let me take the dogs outside. They need to go to the restroom. I'll be right back. Okay, I'm back. Okay, I'm back. I'm sorry about that. So, where was I? Oh yeah, what we're looking for is x. What we want to know is, well, what type of angles do we have, right? So looking at what we have an exterior angle and we have an interior angle. They're on the same side. So I know that these two angles are actually going to be congruent to one another. Now, that really is going to help us out, because what we need to do next is just understand what the word congruency means. The word congruency means to us is that we're going to set these two equal to each other. So I'm going to go 8x minus 4 is equal to 6x plus 12. Okay? And that's great for us because, again, all we have to do is a two-step equation here. This is something that we should feel comfortable with, where I get to use the subtraction property of equality to be able to get all the variables on one side. So I end up with 2x minus 4, that is equal to, remember that simplifies to 0, to 12. And then I go ahead and I add 4 to both sides. That simplifies, and then I end up with 2x is equal to, remember this is plus 14, sorry, plus 4. And it ends up to be 16. So all I have to do is do the division property of equality, and I end up that x is equal to 8. And now remember, the instruction said is what is the value for x? X for us is going to be simply just 8, which is perfect. Okay. The next one says find the measurement of the one that's indicated. So when you read something like this, what I'm looking for is I want to know what this angle is. I want to know what 10x minus 5 is. Remember in the last time, or the last webinar that we talked, we remembered, or at least I hope you guys remember, is that the interior angles of any triangle always add up to 180 degrees. But if you notice this part here, we really don't know nothing about, right? So what is it that we can do to be able to help us understand how to figure out what W is? Well, it just so happens that we have, I guess, a formula or a theorem that says the following. If you know the exterior angle, and you know that you have two opposite interior angles, okay, you're basically going to add the two interior angles, these two right here, You're going to add them up, and you're going to set it equal to the exterior. So what does that mean for us? Well, we're going to have angle W. Okay, let me erase that really quick. We have angle W plus angle V that is equal to angle AUV. Okay, that's what I'm saying. What I want to do now to it, okay, is I'm just going to substitute what I know. So I have 10x minus 5 plus 93, remember that's degrees, that is equal to 11 plus 21x. Okay, and then from here, we're going to do what we've been doing since the beginning. We're going to be basically combining things that are alike. So I'm going to combine these two because those are two numbers. So I'm left with 10x. When I combine these two, or I add them I should say, I end up with plus 88. That is equal to 11 plus 21x. Now if you notice here, I'm going to first move the smaller variable to the bigger one by simply subtracting. So I'm going to take negative 10x and subtract 10x to both sides. The reason why I'm doing that is so that I can end up with a positive variable as opposed to having a negative variable. Okay, so I end up with 88 on the left hand side, because remember this simplifies to 0, and then I have 11 plus 21 minus 10 gives me 11x. I use the subtraction property of equality again, and I end up with 77. That is equal to 11x. This simplifies, remember, it simplifies to 0, so I don't have to worry about that. And now I get to use the division property of equality, so I get to divide both sides by 11. I'll make some room here, and I end up with x to equal 7. Perfect, I'm done. But if you go back and you read what they said, or what we're asking for, is that we're asking for what W is, okay? W, angle W. So angle W for us is going to be 10x minus 5. So 10x minus 5. So remember, our x is 7, so I have 10 times 7 minus 5, so that's 70 minus 5. Okay, so now I have 65. So the measurement of angle W right here, as you can see, is going to be 65 degrees. That's how you are able to figure this one out. When you go ahead and you read number 14, it's basically telling you, look at what I'm giving you, right? Look at this part right here, and I'll highlight it for you. And I want you to basically create a map to it, right? This is something that we did before. We were able to look at what was given to us. So I'm going to go ahead and write it over here. I have triangle LMN that is congruent to triangle LTR. Okay? Remember, what we want to first address here is that we want to first address what the angles are. So those are the first ones that I'm going to mark. I'll mark those in red. The first letter is the first angle that's going to tell me that L is congruent to L. That's the first thing that it's going to tell me. The second thing that it's telling me is that angle M is congruent to angle T. So angle M, it's up here. I'm going to mark it with two little markings. Is congruent to angle T, which will be this one right here. And then the last one is that angle N is congruent to angle R. So angle N, I'm going to do three little marks for this one to indicate that they are congruent. Remember what this means. This means that if they have the same marking, they are congruent to one another. That's what that means. Okay, and then remember, when we talk about learning how to map something, we're talking about not only doing the angles, but also doing the sides, okay? So let me go ahead and let me do the sides. So I have triangle LMN that's congruent to triangle LTR. So now this is a line segment that I'm doing. So I'm going to begin at L, and it's going to go to M. and that is going to be congruent from L to T. So L to M, as you see, it goes straight up. That's the first marking that I'm going to do. And L to T, that's the first marking that I'm going to do. I'm going to say that those two line segments are congruent. The next two line segments is going to be from M to N and from T to R. Okay? So once again, look at what I'm doing. I'm trying to make you understand that these are line segments. They are not angles that I'm doing now. Okay, so I'm going from M to N. I'm going to make two little markings there, and then I'm going to say that from T to R has two little markings, so I know that these two sides are congruent. Remember, I'm trying to prove to you how to create a mapping so that we can say that these two triangles are congruent. And then the last piece is going to be line segment L, N, that is congruent from L to R. And those two will be congruent. So LN and LR need three little markings to say that they're congruent to one another. The next one here is basically asking state that two triangles are congruent. So I want you to look at what I give you, and then I want you to tell me, are these two triangles congruent? So are these congruent? So are they congruent? And I'll put a little big or a big question mark here. We'll call this we'll call the first one triangle 1, and then the second one we'll call it triangle 2. Okay, so what I notice about triangle number 1 is that I have angle, side, nothing, angle. So I have angle, side, nothing, right? There's nothing here. And remember, I'm allowed to skip this. I'm allowed to skip a side or an angle, and then I have another side. By looking at the way that I have done this, I already know for a fact that these are not congruent. Okay? They're not congruent because of what's being given to me. Okay? What I have here is I have ASS, and we don't have ASS in geometry. Remember that we talked about this. Even if you decided to go the way that I'm reading this, okay, the way that I'm reading this, I'm starting here, then I go here, I see nothing here, and then I go here, and I have something there. So I have angle, side, nothing, and then I have another side. So that's not going to help me. So automatically I can say that these are not congruent. Remember all the ones that we've talked about before. You can have the angle, angle side, side, and all that fun stuff, side, angle, side, and then be able to say and prove that these two are congruent with one another. I'm going to do another example just like the last one so that you can see I have side, angle, side here. So I have side, angle, side. For the next one, I'll begin here. So I have angle, side, nothing, side. So I have angle, side, side. And we know that these two cannot be congruent. In order for them to be congruent, they both have to be either side, angle, side, or any of the other triangles that we have, but never ASS. Remember that. It's a key part for you to remember that we will never have ASS in geometry. Just keep that in mind, okay? So let me go ahead and then move on to the next one. So the next big thing that we talked about in G1 was translations and how to be able to move each point that I give you or each figure that I give you. So what you really have to take into account is look at this shape that I have. Okay, so look at this one here, this triangle here. And how do I get that to be moved? That's what I'm basically asking you. How do I get it to be moved, right? So how do I get that to move from, either going up or down or left to right? The first thing that you have to know is that every single point here, okay, so every single point here has an x and a y value to it, okay? So it has, B is located at, if here's the origin, that's your 0, is located at -1, 2, and then F is located at 2, 2, K is located at 3, 1, And what I want you to do is I want you to move every x that you have 2 units to the right and then 1 unit up. That's what I'm basically telling you here. So there's two ways of doing this. You can actually just take every single point and then move it to the right. So I'm going to take B right now, and I'm going to move it 1, 2, and then 1 up. So here is going to be my B, and we're going to call that to be B prime. Remember, we talked about having A prime, B prime, C prime. What does it mean to us in geometry? It means it's a copy of the original. B for us is the original, and B prime is after it's being moved. So I'm going to do the same thing with F. I'm going to move it 2 units to the right and then 1 up, which will be here. So here's F prime for me. And then I'm going to do the same thing for K. I'm going to move it 2 units to the right and then 1 up. And here is my K prime. And now I'm just going to connect them. So let me go ahead and get some, I'll put it in red this time. So we go from from B prime to F prime, from F prime to K prime, and from K prime to B prime. This red new triangle that you see there, that's the new one that that we have created. So that will be the B prime for us. So B prime is now located at 1, 1, 2, 3. That is located at 1, 3. F prime is located at 1, 2, 3, 4, 5. 1, 2, 3, 4 at 5, 4. And then K prime is located at 5, 2. Right? And here it is. I put it in the dark so that you can see with the black marking. So having said that, this is one method of using to be able to move. You can easily take let me make some room here. You can take the original you have, okay, so this will be method number 2. The original for B, remember, it was located at -1, 2. And what you're going to then do is create B prime by doing exactly what it's telling you to do. Add 2 to the original that you have. So you're going to go 2, and you're going to add it to what you already have, so it'll be -1. And then Y, remember what we did to Y? We moved it +1 up, or we added it, so we have 1 plus 2. And B prime moved to 1, 3. And as you can see, here's B prime. And you would do the same thing for F and K. You just basically add what you know, and that's how you get F prime and K prime, okay? Now this, of course, is just when you translate. When you're basically keeping the same shape that you have and you are moving it. That's all you're doing to this. You're learning how to move the shape that I give you up or down, to the left, to the right, or a movement to the left, then up, or to the left, then down, or right up, and then right down. It all depends on what I give you. Personally, I love drawing the picture, and then I love doing this. I like doing the math. I really do, because now I know exactly where it is. So instead of me being here and learning how to count from here, just counting, I just want to make sure that I know where B prime is. So I like to use the other method. Okay? The next one that we're going to talk about is going to be about reflection. Okay, and I have to be honest with you. There are 2 ways of doing this. I'm going to do it just by counting, because I think that everybody in class decided to remember it that way. But there is another way of doing it. So what I want to do is I want to reflect. So I first need to figure out, where am I going to reflect? I'm going to reflect it on the y-axis. Okay, that's what I'm going to do. And I created a line here, a red line, so that you can see. I'm going to take every single point, and then I'm going to put it across. I'm going to take every single point, and I'm going to put it across. So that's what I'm going to end up doing here. The question to it, of course, is going to be, well, how do you get yourself to be moved across the y-axis? There's two ways of doing this. The first way that I'm going to do it is I am going to just count. How many units am I away from the origin? Okay, I'll put it in a little highlighter here with a purple. That's the origin for us. How many units did I move away from there for each point? Okay, so if you look at this one, I'm going to start off with C. So I have 1, 2, 3, 4. I move 4 units away from the origin. So C prime is going to be the same distance going the opposite direction from the origin. So it'll be 1, 2, 3, 4. Here is my C prime. U, we went 1, 2. I'll put it in different color so you guys can see. 2 went 1, 2, 3, 4, 5. Okay, so this one went 1, 2, 3, 4, 5. Here is my U prime. How many units did I go away for Q, let's say? I went 1, 2, 3, 4, 5. I'm going to do the exact same thing here. 1, 2, 3, 4, 5. Here is my Q prime. And then R is 4 units away, so I'll put that one there in a different color. 1, 2, 3, 4. And here is going to be my R prime. And all I want to do is actually go ahead and combine these, right? So I know that we have C goes to U prime, U prime goes to Q prime, Q prime goes to R prime, and then R prime goes to C prime. And there's that shape that we were looking for, okay? Maybe I should have done it in a different color. Let me try to see if I can still do it. Yellow, maybe. Green, blue. Yeah, let's do it with blue, as you can see it. So here it is. This is what I was talking about. So all you've done is you reflected it on the y-axis. I could also ask you to reflect it on the x-axis, and you could do something similar to it as well. What do you notice about C? C, so this is the second method. C is located at -1, -2, -3, -4. It's located at -4, and then it went up 1. Well, what do you notice about C and C prime? C prime is located at 4, 1. When you reflect on the y-axis, look at what happens to the x. You basically are multiplying your pre-image, okay, which in this case will be C. You're multiplying it by a -1, and then you're moving it across the y-axis, meaning y will stay the same. You just basically multiply x by a -1, and you'll be able to get it to the other side. Okay, it will work both ways. Now, if it was the x-axis, then you would just need to multiply the y by a -1, and it'll reflect it on the x-axis. Okay. The next one that we're going to talk about is going to be rotating from the origin, and I'm going to rotate this 180 degrees. And the question to this is, okay, so if I'm going to rotate this 180 degrees, well, what is it exactly that I need to do? Well, there are two ways of doing this, and I'm going to show you the other way because the other one was about counting. This one, you actually have to use a little bit of understanding about coordinate plane, you know. So V for us, V is located at, if this is the origin, it's located at -1, -2, -3, comma 1, 2. And what I want to do is I want to rotate every single point that we have. So I have to figure out where S and J is. So S for us is going to be at 1, 1, 2, 3, 1, comma 3. And then J is located at 1, comma -1. Okay? So that's where they're all located. So in order for this to work, we have to basically reflect it on the X, and we have to be able to reflect it on the Y. And the way that you would do this, so I'll take the first one, I'll take V. V is located at -3, comma 2. Let me make some room here. So V for us is located at -3, comma 2. And if I'm going to reflect it 180 degrees, what's going to end up happening is that I need to multiply the x and the y. So I need to multiply by a -1, both on the x, okay, and on the y, and then I'm going to interchange them. Okay, I know it's kind of weird to understand, but I'm going to take my x, as you see here, this is my y, I'm going to take my x, I'm going to multiply it by a -1, and then I'm going to put it for my y. So -3 times -1 gives me +3, and as you can see, that's where I put it. I'm going to take what I know about y, I'm going to multiply it by a -1, and then I'm going to put it where x was. So this will be -2. So v for me is going to be located at -2, so it'll be 1, 2, -2, and then +3. 1, 2, 3. So here will be my v prime. I get it. I know it's a little weird to understand. It's not exactly what you expect, but once you fully see the picture, you'll understand what I'm talking about. Okay. Let me change this to blue. So we said it was located at -2. 1, 2, 1, 2, 3. So here, v prime. And then you will do the same thing for s. S is located. Okay, so s is located. So this will be v prime. S is located at 1, 3. I'm gonna go ahead and do multiplication, then switch them, so I get -3, -1. So 1, 2, 3. Here is where S prime is located now, and J is located at 1, -1, and I'm going to do the whole transformation, so I get 1, -1. So I go to 1, -1. So it stays right where it is. And all I'm going to do now is I'm going to go ahead and connect them. So here is the new one that I have. And remember, I'm taking the origin. Oops. I'm taking the origin and I'm basically rotating it. And as you can see, a good way to figure out if you did this right, look at where one of them begins, like S, and then look at where it ends up, S prime. They should be completely opposite to one another. One of them should be, so that you can see. Super easy to understand. But again, you have to remember those little things that we've been talking about, right? Those little hints of learning how to multiply and what to multiply and what to do and what can you do with it. Okay? So we'll go ahead and we'll continue. When we look at this one here, the instructions you can't see because I forgot to copy them. But basically it's saying look at the figure that's given to you and what can you tell me about it. Okay? So that's going to be very important for you to understand. This line here in red, that's little v. Then you have point G, point F, little, I'm going to call this little w because I can't see it. And I'm going to call this little L. This is point D, point E, and then point C. It's located there. Point E is there, point D is there, point F is there. Okay, so I'm going to write down all the information that I get to see from this particular picture. I'm going to go from this right here, this dot is where I'm going to start. And I'm going to go down and I'm going to see what I can see. I see that line segment FG, okay, so line segment FG is the first thing that I see, is perpendicular to line little v, okay? And that's, how do I know that? It's because it's being marked here, okay? I'm highlighting it there for green for you to see, right there. Or I will highlight it so you can see. That's the first piece of information that I see. Then I'm going to continue. I also see, Okay, I see that line segment FG is congruent to line segment ED. As you can see, because of the two little markings that you have here. What else do I know? Here's another one. I know that line little w is parallel to line little l. Okay, how do you know? It has the little markings here in red that you can see. And let's see, what else do I know? Oh yes, I also know that measurement, or the angle measurement of E, is congruent to the measurement angle D because of what's being given to me here. I know that. So remember, when you get a shape like this, what you want to do is you want to take a step back and you want to be able to see what's being given to you before you do anything else. Okay, so that's the most important thing about this particular example. So here's a good example. This one talked about the exterior angle. We kind of talked about it in the last example, but I also wanted to take a look at it in a different way so that you can see it. Perhaps in an easier way with less math and just more of an understanding of what it is that I am giving you. I'm basically giving you two interior angles, we'll call it X, and then I'm going to add it to 65, and I'm going to set it equal to the exterior angle here of 110. And all I want to do is basically solve for X and then be able to know exactly what this angle is, right? So all I need to do now is take 110 minus 65, and it's going to give me that X is equal to 45 degrees. So X here is going to be 45 degrees. Again, I put this example here just so that you can see the exterior angle theorem in a different way with less mathematics but more understanding of what it is that the exterior angle does for you, okay? So it's something that you need to remember. It will be in the final, so try to remember it as much as you possibly can, because we are not going to run away from that. Okay, so let's go ahead and let's look at this proof that we have to do. Now remember, when we did the proofs together, we did them as a paragraph. We did it as a class, and we said, hey, look at what's being given to me, and let's go ahead and let's try to figure this out together, right? We said, once we understand what I am able to see here, then I could put it into words, and I can be able to basically give all the information that I have. So first of all, look at what is being given to you. Okay, I'm gonna highlight it in yellow so that you can see all this information that's in yellow is what I basically give you, and the one that's in green, where it says prove, that's what you have to be able to prove to me. You have to be able to look at all the information that I give you and then say, okay, based on all this information that's given to me, I could go ahead and I can prove that AB is going to be parallel to DE, right? But you cannot assume that. Please understand that. You cannot assume that. You have to be able to prove that. How do you prove that? Well, let's make the markings together. I'm telling you that AB, okay, so that AB is going to be congruent to DE. So far we know that they are congruent. Whatever the length is there, okay, between AB right here and DE right here, that right there, whatever that length is, they are congruent. They're going to be the same. The next piece of information that I know is that C is a midpoint of AE. So here's A and here's E. C is right there, and that will be very important for us to understand. So C is the midpoint of A and B. So that means that this part right here and this part right here, so AC and CE are going to be congruent. Based on what's been, based on what they gave us here, we can definitely see that they are congruent of the understanding of the definition of what a midpoint is, right? Then the last part that they tell us is that AE, okay, so AE that is this entire line that you see here, and that BD, as you see here in blue, BD, is perpendicular. Okay, so that's good for us. That's very good for us to be able to understand what the word perpendicular means to us, okay? Perpendicular means that it creates 90 degrees. Okay, so far look at what we have. We have really good information here to be able to determine what type of triangles we have here. So let's basically break it down and let's look at what we can say. We have to really think about it. We can't just jump in there and be able to say, oh, I know that they are congruent because of the picture itself. You can't just go ahead and say that. You actually have to be able to prove that that is true. So let's break it down into smaller pieces of information, and I'm gonna say that we have line segment AC. Okay, remember we talked about that. I'm gonna begin with that one because it's very important. That is congruent to CE. This is the statement that I'm telling you, and I'm gonna say by. I have to always prove to you that I know that I'm talking about. I can't just assume something. So I'm going to say that by the definition of midpoint, I can claim the following, right? That AC is congruent to BC. So that's the first piece of information. Then I can also say the following, that the measurement of angle ACB is, well, it's not is, and I should say the measurement of angle ECD, they are basically going to be vertical angles, right? How do you know that? Because look, here's 90 degrees right here, and here's also 90 degrees because of the perpendicular, because of right angles, we can say that. And then in addition, we can say because of the definition of perpendicular lines, right? Perpendicular lines. So we can say all this because it's true. I can create 90 degrees. We know that they're vertical angles, that they're right angles, and that they are perpendicular, so then we have that piece of information. So now if I have a 90 degree, as you can see here, and I'll highlight it for you in light blue, we have this one right here. We know that we have vertical angles are 90 degrees, and I know that it's a right angle. I can look at the markings that I have now for AB and DE, and they are congruent, they're the same. So now I have something that's very unique. Now I can say the following. So this is the first thing that I said. Here's the second thing. And now I can tell you this. I can say that triangle BAC is congruent to triangle DEC. How do we know this? Well, it's by the hypotenuse-leg theorem that we talked about, right? If we have a 90 degrees and we have the hypotenuse be the same of two different triangles, then they are congruent because they have a 90 degrees and the hypotenuse is the same. So that's very important for us to say. So now, okay, so all of this is the information that we've talked about. So now I can say this. So now, comma, I can say that angle HL means that the hypotenuse. Remember, if we have a right triangle, this is a leg, and this is called the hypotenuse. And we know that it's 90 degrees is always opposite of the hypotenuse. So because of that piece of information that you see here, I can claim that HL means that the hypotenuse leg are congruent of the two sides, as you can see here with the little marking that I did for you. Because of that, I can say that they are congruent. Now I could also say that angle A is congruent to angle E, right, by CPCTC. Congruent parts. Uh, Congruent parts are congruent of a triangle. I always forget this, but you know what I mean. CP, CTC. Okay, and so therefore, and then the last part to this is going to be, remember the three little dots and what it means as a mathematician. It means so therefore, or in conclusion. Now I can say that I have a B line segment AB being parallel to line segment DE. And how do I know that? We also have alternate interior angles, right? That's the theorem that we talked about. So alternate interior angles that we have, this one here and then this one here, from the previous step that we just talked about. So you can see there's a lot of information here that's being given to us with, with just a couple, with just a couple of hints that they gave us here, and I underlined for you right here in black, as you can see, and then the red right here, and then the blue that's in a box here. Those three things, with those three things here, we were able to prove that these two triangles are congruent. Something like this is going to be very crucial in the final. You're going to need to know. Sometimes as teachers will ask you, look at the following example, look at the following steps, what's missing, and then I can take one of these away, and then I'm going to ask you to go ahead and make a choice from all of them, okay? Congruent parts, congruent triangles are congruent. I think that's what that means. CPCTC. Congruent parts of a triangle are congruent, okay? I think that's what it means. Let me look it up really quick. I just want to make sure. Congruent, CPCT, congruent parts. I had it here. Here we go. Let me read it to you. Okay, so CPCTC stands for the following. Corresponding parts of congruent triangles are congruent. There you go. I'm so sorry. Okay, so CPCTC. Corresponding parts of congruent triangles are congruent. That's what that means. Okay? Let me see. I think that was the last example that we had for the night. Do we have any more questions before we call it quits tonight?